Electrostatics is the branch of physics that deals with electric fields and electric charges at rest. Electrostatics as a field of physics contributes about 25 to 30% of the questions in board exams and competitive exams. It is probably one of the most important fields among all the fields in physics. So let's get started. Let us understand the interaction between 2-point charges. The property which differentiates between two different kinds of charges is called its polarity. The polarity of a charge can either be positive or negative. We know that two like charges repel each other and two unlike charges attract each other. Let us say we have two positive charges as shown here. Now, as both of these are positive charges, that is, they have the same polarity, hence they are like charges. Hence, they will repel each other. That is, there will be some repulsive force between the two. Let us say we have two negative charges as shown here. Again, as both of these charges have the same polarity, that is negative, hence there will be some repulsion again. There will be some repulsive force between these two charges. Let us take two charges as shown here now. Now, one is positive and the other is negative. Now, as both the charges are opposite in nature, hence they are unlike charges. There will be some force of attraction between them. Let us now replace the polarity of the two charges by the magnitudes of the charges. Let's say the magnitudes of the two charges are Q1 and Q2. Let us say the distance between the two charges is given by the letter small r. Look at the first case here. We have two positive charges whose magnitudes are Q1 and Q2, and the distance between them is equal to r. Now, as both of these are having same polarity, that is, both are positive, hence there will be some repulsion between them. This force of repulsion is denoted as follows. The force which acts on Q1 due to Q2 is denoted as F12 with 12 in the subscript. Similarly, the force which acts on Q2 due to the charge Q1 is denoted as F21, where 21 is in the subscript. Look at the second case here. We have two charges, one which is positive and one which is negative. Here, as both the charges are having opposite polarity, hence they are unlike charges. Therefore, there will be some force of attraction between them. The force which acts on charge Q1 due to Q2 is denoted as again F12 with 12 in the subscript. And the force which acts on charge Q2 due to Q1 is denoted as F21 with 21 in the subscript. The magnitude of these forces is given by the Coulomb's law. Also, it's important to note that the forces F21 and F12 are equal and opposite in direction. The Coulomb's law gives us the direction and the magnitude of the force acting between 2-point charges separated by a certain distance. Let us say we have 2-point charges which have magnitudes equal to QA and QB, and these two charges are separated by a distance r. Then the Coulomb's law states that the magnitude of the electrostatic force between these 2-point charges is directly proportional to the product of the two charges, that is QA multiplied by QB, inversely proportional to the square of the distance between them, which is r square, and this force acts along the line joining the 2-point charges, which is given by the unit vector r cap between the 2 points. The formula to find the electrostatic force between the 2-point charges is as follows. To find the force acting on QA due to QB, we write it as F AB in subscript equals 1 by 4 pi epsilon naught QA QB upon r square r cap BA. Here, 1 by 4 pi epsilon naught is the constant of proportionality. It's approximately equal to 9 multiplied by 10 raised to 9 units. R is the distance between the two particles, QA and QB. R cap BA is the unit vector from QB to QA. This gives us the direction of the force acting on A due to B. FAB is the force acting on QA due to QB. QA and QB are the magnitudes of two charges in coulombs. Let us solve a few questions based on Coulomb's law. Question number 4 from the lecture notes. The question is, 5-point charges, each of value q, are placed on 5 vertices of a regular hexagon of side L. What is the magnitude of the force on a point charge of value minus q coulomb placed at the center of the hexagon? Now let us first understand and comprehend the question and make a diagram based on the information given to us. Here we have been told that 5-point charges, all positive, q plus q, are placed at the vertices of a hexagon. We know that hexagon will have 6 vertices. So out of these 6 vertices, at 5 vertices, we have 5 positive charges plus q. One vertex will not have any charge. Also, another charge minus q is placed at the center of the hexagon. So we get the diagram as shown. The 5-point charges are placed at the vertices B, C, D, E and F of the hexagon. Another charge minus q is placed at the center of the hexagon, which is the point O as shown in the figure. Now, as the force between 2-point charges is always vector in nature, hence the force on minus q due to charge at F will get cancelled out by force on minus q due to charge at C, as both of these forces are equal and opposite in nature. Similarly, force on the charge minus q due to the charge at point E will get cancelled by the force on charge minus q due to the charge at point B, as again both of these forces are equal and opposite in nature. So therefore, the only force that remains is the force due to charge at point D. Hence, the net force will be equal to force due to charge at point D, which is equal to F OD, which is 1 by 4 pi epsilon naught, product of the two charges, which is q multiplied by minus q, divided by the distance between them, which is equal to L square, which is 1 by 4 pi epsilon naught q square upon L square. Hence, the magnitude of the force acting on the charge kept at point O is equal to 1 by 4 pi epsilon naught q square by L square. Also notice that the distance L is the distance between points O and point D. Now, in a hexagon, this distance will be equal to the side of the hexagon, as ODC is an equilateral triangle. Hence, all the sides will be equal to L. Question number 6. 3 identical spheres, each having a charge q, uniformly distributed, and radius r, are kept in such a way that each touches the other two. Find the magnitude of the electric force on any sphere due to the other two. Let us first understand and comprehend the question. We have 3 spheres. Let's say the 3 spheres are sphere A, sphere B, and sphere C. The 3 spheres are touching each other. Therefore, the centers of the 3 spheres, the line joining the centers of the 3 spheres, will be an equilateral triangle. Let's say the centers are at points A, B, and C. Hence, ABC will be an equilateral triangle. Let us say we will find the magnitude of the force on sphere A due to the other 2 spheres. Now, the force acting on sphere A due to sphere B will be along the line BA. As both of these are like charges, therefore, the force will be along the direction as shown. Similarly, the force due to C on A will be along the line joining the 2-point charges, that is CA, and the force will be again away from point C, as both of these are like charges. Let us now find each of the magnitudes. The magnitude of force on A due to B is equal to FAB, which equals 1 by 4 pi epsilon naught, the product of the two charges, which is q multiplied by q, that is q square, divided by 2r whole square. Now here, the distance between the points A and B is twice of the radius of each of the spheres. So that is why the distance is 2r. The magnitude of this, that is only the value without taking the vector, is 1 by 4 pi epsilon naught q square by 4r square. Similarly, let us find the force on sphere A due to sphere C, which will be FAC, which equals 1 by 4 pi epsilon naught product of the two charges, which is q square, divided by the square of the distance, which is 2r square, r cap CA. The magnitude will be equal to 1 by 4 pi epsilon naught q square upon 4r square. Therefore, we see that the magnitudes of the two forces are equal. Also, as ABC is an equilateral triangle, hence the angle between the two forces FAB and FAC will be 60 degrees. Now, each of these forces is vector in nature. To add two vectors, we'll use the formula Fnet equals square root F1 square plus F2 square plus 2F1 F2 cos theta. Here, F1 and F2 are the magnitudes of the two forces. Theta is the angle between the two forces, which in this case is equal to 60. So when we substitute, we get square root of F square plus F square plus 2F square cos 60, which is equal to root 3 F. F is equal to 1 by 4 pi epsilon naught q square by 4r square. Hence we get root 3 q square upon 16 pi epsilon naught r square. This is the net force acting on sphere A due to sphere B and sphere C. Question number 30. 2-point charges Q1 equal to 20 microcoulombs and Q2 equal to 25 microcoulombs are placed at points -1, 1, 1 meters and 3, 1, -2 meters with respect to some coordinate axis. Find the magnitude of force acting on point Q2. This is a simple question based on Coulomb's law. First, we'll find out the distance between the two charges Q1 and Q2. Here the 2 points are -1, 1, 1 and the coordinates of the second is 3, 1 and -2. We know that the distance between these two can be found by using the distance formula. Here, using distance formula, we get the distance between the two charges Q1 and Q2 equal to square root of 3 minus -1 whole square plus 1 minus 1 whole square plus -2 minus 1 whole square, which we can evaluate and is equal to 5 units. Now, therefore the value of r, which is the distance between the two charges, is 5 units. Also, we have been given the magnitude of the two charges. Q1 is 20 microcoulombs and Q2 is 25 microcoulombs. Let us substitute each of these values Q1, Q2 and R in the Coulomb's law formula. We get F Q2 Q1, which is the force acting on Q2 due to Q1, equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square, which is equal to 9 into 10 raised to 9, that is the value of the constant 1 by 4 pi epsilon naught, multiplied by Q1, which is 20 into 10 raised to -6 coulombs, multiplied by Q2, which is 25 into 10 raised to -6 coulombs, divided by R square, therefore 5 square, which is equal to 0.18 newtons. Hence, the magnitude of the force acting on charge Q2 due to charge Q1 is equal to 0.18 newtons. Your assignment for today's session is given below. Do ensure you complete your assignment before we start with our next session.